6 things you must do to optimize your database. A crash course on database query optimization basics. Welcome back to StartupHakk. With my 25 years of development experience here at StartupHakk, we turn beginners into full-stack developers in as little as 3 months. As your database grows, queries will inevitably take longer and longer to execute. This means slow data retrieval usually leads to a worse user experience. Google got popular not just because of their best-in-class search, but also the speed of their search. So smart query planning and query optimization can help hold off the need for drastic scaling strategies like sharding. So let's dig into index creation and management. Indexes are one of the most important tools for query optimization. They're a special lookup table that the database search engine can use to speed up data retrieval. So how do indexes work? Imagine an index being a book. Instead of reading the whole book to find a topic, you use the index to look up local pages containing your topic. Similarly, database indexes help locate data without scanning the entire table. So let's talk about the different types of indexes. So common type of indexes include primary key indexes, unique indexes, and composite indexes. So some of the best practices around indexes are to balance the need for quick reads against the performance cost of write operations. For instance, if you put an index on every single column, it wouldn't perform well on a write. It might really help the reads, but it wouldn't help on the writes, and therefore the trade-off isn't worth it. So you want to be selective as to which columns you add an index to. So let's talk about analyzing and utilizing query execution plans. So a query execution plans are detailed roadmaps about the database engine and about how it executes the query. Understanding these plans is vital for optimization. So most database systems can generate a query execution plan, which shows the step-by-step process of how the query will be executed, including which indexes will be used. So now you can read these execution plans, and they'll help you identify bottlenecks such as full table scans or inefficient joins. So let's talk a little bit about a real-world example. So imagine that we have a database for an online retail store with 2 tables, customers and orders. Now the objective is to run a query to fetch names and email addresses of customers who made purchases above $500 in the last month. So your SQL query would look probably something like this. So generating and analyzing the execution plan can help you identify the need for indexes and inefficient joins. So let's dig into addressing bottlenecks and optimizing queries. So you want to create indexes, and since the orders table is being fully scanned, create an index on order date and amount to significantly speed up the query. Now you might look at revising the joins. Nested loop joins may be inefficient with large data sets. Consider using a hash or a merge join instead. So we definitely would want to create an index on the orders table. We'd also want to choose a more efficient join method based on the data size and distribution. So after making changes, run the query again and check if the execution plan has improved. Now each database engine like MySQL, Postgres, or SQL Server has its unique optimization techniques. Now you want to really dig in and get into the specific techniques for your type of engine. So for instance, MySQL's strength is storage engines such as InnoDB or MyISAM, indexing strategies like B-trees and full text. For Postgres, some of its strengths are advanced index types, MVCC, concurrency control, and some other things. Some of the other things that you may want to look into is the memory allocation, caching settings, and query execution parameters can be tuned for different performance based on what your application needs. So you want to make sure that you're looking at the InnoDB buffers pool size for MySQL, or look at shared buffers for Postgres. Now for caching settings, you want to look at configure cache sizes like query cache size for MySQL, and then you also want to look and tune parameters like join algorithms and query timeouts. Now you may also want to be able to adjust the logging and checkpointing. Adjusting the frequency and the granularity of logging and checkpointing can impact performance. If you have this turned on too high, it can inversely affect the actual performance of the database, whereas if you turn it down too low, you may not get the logging which you need. So for SQL Server, transaction log backup frequency affects the write performance. For PostgreSQL, adjusting checkpoint completion target for a balance between write performance and recovery time. Now, your best practices are, you really want to look into the transactional log. Make sure you optimize for the right level of detail. You want to balance recovery time against performance so you don't degrade the performance due to frequent checkpoints. So the way a query is written can significantly impact its performance. And this is a big reason why I like using frameworks such as Dapper instead of using a lot of ORMs that hide the actual queries. So you want to avoid selecting unnecessary data. You want to use select judiciously, specifically only the columns that you need. You also want to use joins effectively. Understand different types of joins and use them appropriately because these have a huge impact on your query speed. You also want to check aggregate functions and grouping. Misuse of functions like count and sum can lead to delays, especially with large data sets. So again, like I said, instead of using select star, specify write columns required, so instead do select name, email from customers where active equals 1 instead of select star. So what are your thoughts? Do you agree? Do you disagree? Did I forget some of the most important things to be watching out for? What things did I miss? I love having good discussions, so make sure you leave a comment down below and make sure you like and subscribe to our channel. Here at StartupHakk, we love training software developers. With my 25 years of development experience, we take people with zero experience and help to train them to be ready to start as full stack software developers in as little as just 3 months. So make sure you check out the link down below or go to startuphakk.com today.